Alrighty, welcome back. It is Friday. Our man Brad Perry is up in La Jolla right now, checking out some really interesting robots that actually could help maybe save some lives. I mean, these are really functional. Good morning.
Good morning, Dan. We are, and I'll tell you now, I have the pleasure of getting to tell the lighting guy to go out and light the smoke. Lighting guy, are you ready? I'm ready. Lighting guy, go light the smoke. As he's heading out that way, Tom here, we're talking about something that's great you guys are experimenting here, and that's with computers and, of course, helping out those in need of, like, the oil spills, the fires, and different things like that.
Right, exactly. So we're really trying to figure out how to figure out where a smoke plume is and where it's about to move. Could be used for fires, which is of interest in California for sure, also for oil underwater, for ash over Iceland, all sorts of situations we can use.
And you saw how quickly those robots went right with that smoke, and that's something that you guys are trying to fine-tune here.
Right, so we're trying to figure out how to actually route these vehicles automatically. This particular test right now, they're again under handheld control. An earlier test this morning, a couple earlier tests, we had them actually controlled by a supercomputer and moving completely autonomously, going and getting that information that we need, like that one that's moving right in that smoke plume there, getting the information that we need in order to figure out where the smoke is going and where it's going to go next.
Now, are the computers, this actual size that are on the robots that are out there, are the robots bigger and the computer bigger?
So the computer is huge. The computer is off-site, and these guys are communicating with it. So all of these things they're doing are little sensor vehicles. So right now in a parking lot, this is appropriate size vehicles to use. If we were going to be measuring oil, we would use underwater vehicles, different type of vehicles. If we're going to be in the air, we'd use unmanned aerial vehicles. But the technology back in the supercomputer is all similar. So there's a big flow. We need to update it with information, and we need to get the information from there back to the vehicles to tell them where to go to get the next information that we need.
Very cool. Now, if I'm a student watching this and I want to get into robot stuff, is this part of a grade here they have to make sure this works?
Yeah, so this project that you're seeing here is actually quite high-tech. It's 5 different PhD theses coming together. But here at UCSD, we have in the Coordinated Robotics Lab, robotics.ucsd.edu, we also work with a bunch of undergraduates as well. And actually, in spring quarter, we worked with about a dozen undergrads working on various aspects of building up these vehicles, building up the GPS units that you see sitting on top that are figuring out where they are and measuring the wind and the smoke and things like that. So we work together with a large team, and it's really anchored by the 5 PhD students over here who are making it happen.
So this is it right here. If they get this, they've actually graduated with a PhD.
They're close. They're close.
Yeah. This is their grade right here.
They need to write it up.
You make the judgment. Who makes the judgment?
I make the call.
You make the call. Guys, he makes the call. You know, that's why they're kind of nervous. They're kind of like hoping that this works, especially on live TV. But so I'm going to ask you, guys, here goes the test right now. What do you think they've done so far? A+, B, where are they at right now?
A+, I could go higher if I could.
Oh, okay, you guys, A+. Call today. It's a weekend. You guys are called today. That's what we're talking about. Get the party smoke there, Dan. We're out of here. We can pull one of these over to the side, bring us around some cocktails or something. It's a party now. We got us an A for the weekend, guys.
It is cocktail time.
Woo!
All right, I'm joining Brad, whatever he's doing.
We got an A, dude.
I'm joining
We got an A.
He's
Come on,
just
Val Kimber,
close it down. He's shutting down the
hair. We got an A. Long hair guy, A. We're awesome. I'm back in college again, man. This is awesome. So we're like
all right, Brad. Thanks a lot, buddy. Get out of the way of that smoke, by the way.
Perry's up in La Jolla. He is checking out some robots that actually could save your life.
His entire life is a weekend. Good morning, Brad.
That's true.
You know what? I'm inviting these guys down. They need to have a little. You guys, I'm playing at Gordon Bierce tonight over here in Michigan. Come on down. Some good music. That's with Sean Johnson Foundation. You guys deserve it after all you've done, especially this guy right here. 25 hours of working on this. And I'll tell you, I'm sorry, Val, because it's Val Kimmer. That's what he looks like from Real Genius. But he looks at Chris here and goes, "Where's Chris?" So get some rest and come down and see me play. I'm going to send out Chris right here, the lighting guy. Go out and light that up, because this is what we're doing out here. Oh, you can't light yet? Okay, you can't light yet. We're going to talk to David. David, this program you guys are doing here is so important, but I want to talk to the student about it, because this is your thesis here.
Yes, it is. And among my thesis, there are also 3 other PhD students' theses as well.
So, and you guys actually are going out here testing these robots that will be used in the future. And I got to ask you, is this something that, you know, when you're looking for a job after all this, is something that's going to definitely be on your resume?
Oh, definitely. Because what employers look for are people who can use theory and then apply to the real application, and there's no better demonstration than this.
Wow. Okay, let's talk a little about the demonstration that we were doing here. So we've been watching the computers. I know they're a lot smaller than what you guys would probably use on a bigger level, which is real nice. And Mike, you got to get out of there before you... Mike, get out of there! They're about to launch. So, so what's going to happen now when he lights?
Once it lights, the smoke canisters gotta start generate smoke, and you can see a color smoke coming out of it. And as the smokes are emitting from the pot, and then the robots have started moving, gathering smoke data, send it back to a supercomputer where the data is gotta be analyzed, and then a sequence of waypoints is gonna be sent back to this robot, and that will tell where the robot's to go.
Yeah. And now we're also using colored smoke, and don't do this at home. These guys are trained professionals, but we're using colored smoke just so you guys can use it for pretty much for the simulation. But in real life, you guys wouldn't see smoke or gases or anything.
Exactly. Like it could be colored smokes, like for example, like carbon monoxide and other type of smokes, or even chemicals, biological contaminants.
So it's very cool. So I've learned a lot out here, and they've actually, like they said, these little computers are going back to the supercomputer and working together. And it's more for a show with the color but doing, but amazing what they're doing out here. And eventually they'll be able to take this to the Gulf for oil spills. They'll be able to take it for fires, for gas leaks, for all kinds of things. So that's what they're hoping for. And as I said, it's just a simulation here, right? But I'll tell you, Dan, you guys, this is so cool to watch you guys. And again, so far they've gotten an A. And been kind of fun. And I'll tell you, as we had the curly hair guy and long hair guy, they actually worked on, they were undergrads working with them on this, and so they're eventually becoming a graduate program that's working hard. Chris, how far is Chris? Is this Chris's last year? Is this Chris going to be?
Yes, this will be his last. He probably has some more years to go, like me.
Yeah, like you. But then, of course, Val Kimner over here, who we're calling Val Kimner, he's just starting this, so he has a lot more to go into this project.
Yes, he's going to probably push the project a lot further than we have.
Very like it. So there you go, from UCSD. I almost said USC and they were mad at me because it's Friday. So there we go, experiment going on here, robots, supercomputers, fun. So far, professor said they got an A. And guess what? Guess what?
So far,
they get the road trip tomorrow. They get the road trip to Texas tomorrow. How cool is that?
Really? Where in Texas?
They got to put all the computers in. They're going to one of their sponsors that help them put all this together. And they're road tripping to Texas to show them what they're doing. So guys, tonight, Gordon Biersch, me and Sean Johnson, the foundation, come on down, 8:30. And I want Val Kimner. He's a little tired, but I'm going to tell you right now, you get some rest, you come down, you hang out a little bit. How's that?
See what I can do.
All right, there we go. Val Kimner. I just like that.
Gonna have to check his schedule.
Long hair guy, I want you down there, and curly hair guy. All right? Those are cool guys right there I'm hanging out with. I'm
By the way,
now,
Brad, have you seen the real Val Kilmer lately?
So, not really.
Huge.
Is he here in town?
No, he's really big, shall we say?
Yes, he's gained. Well, that's what I'm saying. That's the young Val Kilmer.
Yeah, that's was the weird genius.
That's a real genius.
Yeah. That's what Val wishes he still looked like,
yet,
I think.
But he's getting there a little bit. So.
Right. He's getting there a little bit.
Uh-oh.
Wait a minute.
We heard the fire trucks.
We heard the fire trucks. Are they coming for you?
What's wrong? We got a fire? We're okay? You know what? I hope they come by.
It's
Tell
a
them to come by.
pretty good blaze there.
I'm Brad Perry from KUSI. Tell them to come on over. I think we're supposed to
Did somebody call the fire truck?
So.
No?
Let's get in trouble.
All right.
Get in trouble. Why not?
See you later, Brad.